Today we're going to be doing 2020 AMC 10A problem number 11. The problem reads, what is the median of the following list of 4,040 numbers? 1, 2, 3, all the way to 2020, and then 1 squared, 2 squared, 3 squared, all the way to 2020 squared. So first, what we need to do to understand this problem is know what a median is. A median is the middle number in a list. So for an odd amount of numbers in a list, for example, if we had the list 1, 2, 3, 4, 5, which has 5 numbers in the list, it has an odd number of numbers in the list, the median would be 3. For a list with an even amount of numbers, for example, 1, 2, 3, 4, the median would be the average of these two numbers. So the average of 2 and 3 is 2.5. So that would be the median in the list. Okay, so going back to the original problem, we have a list 1, 2, 3, all the way to 2020, and then 1 squared, 2 squared, 3 squared, all the way to 2020 squared. So obviously this is not put in order yet. So part of our job to understand and solve this problem is to put this list in order. I'm just going to experiment with the squares of the numbers and see where they can fit into this list. So I know that 40 squared is equal to 1,600, and I know that 50 squared is equal to 2,500. So I know that something in between these two will have to be the cutoff between this part of the list and this part of the list. So since I've already done the problem, I know that 44 squared is equal to 1,936, and I know that 45 squared is equal to 2,025. And so if we rewrite the list, it'll look something like this. And then on the other side will be 45 squared, 46 squared, 47 squared, all the way to 2020 squared. So this is the first part. This is the second part of the original list. Since we want to find the median, this will be helpful in determining where exactly is the middle part. And so what I'm going to do is I'm going to count how many numbers are in each part of the list. So obviously in this part of the list, there is 2020 minus 44. There are 1976 numbers. And in this part of the list, there are 1, 2, 3, 4, all the way to 2020. So that would be 2020 plus 1 squared, 2 squared, 3 squared, all the way to 44 squared. So that would be 44, which is equal to 2,064 numbers. So this is not split evenly. It would be nice if it was split evenly so we can find the median, but it's not. So we're going to have to make these two split evenly. It would be easy just to find the first 1976 numbers, find where to split it, make a separate middle list, and that middle list will make it easier to find the median of this entire list. Our goal right now is to try and find the first 1,976 numbers in the first part of this list. So let's just try splitting the list right here, and let's see if that gets us to the first 1976. So the first, there would be 44, because 1 squared, 2 squared, 3 squared, all the way to 44 squared, and then 1, 2, 3, 4, 5, 6, all the way to 1936. So that actually got us pretty close to the first 1976. We have the first 1980 numbers. So this part right here, there are 1980 numbers here. So all we need to do, hold on, let me just rewrite the list. All we need to do is subtract 4 numbers from this list in order to get to the first 1976. So 1, 2, 3, 4. This is the first 1976, and these are the last 1976. So we can just cross out both sides so that we're left with the middle part. We're left with the middle chunk of this original list, which will help us get closer to the numbers that we want. And so let me just rewrite the final middle chunk of the list. This would be much easier if we just had a list of consecutive numbers, so I'm just gonna cross out some of the numbers to cross out this particular one. So cross out this one and cross out this one. It'll make a shorter list, which is basically what we did here. Cross out this one. So 2017 and 44 squared. Now we're left with an even smaller chunk of the middle part of the list. The final list would look something like this: 1937, 1938, 1939, all the way to 2016. Now what we have here is a list of consecutive integers, which is much easier to find the median of than this original list, which was out of order. For consecutive integers, it's a rule that the mean of this list is equal to the median. So all we have to do is find the mean of this list. The mean of any list is equal to the sum divided by how many numbers there are. So number of numbers in the list. So first we're just going to find the sum. And so for a list of consecutive integers, again, there's another special rule that says that the sum is equal to the first plus the last times the number of numbers there are divided by 2. So now all we have to do is plug in numbers. So the first, 1937, plus the last, which is 2016. And then how many numbers there are. There are 80 numbers in this list. Divided by 2. And so this is equal to 158,120. That is the sum. So we can put this back in here. Divided by how many numbers there are on the list. So we already found out that there are 80 numbers in this list. The mean, which is also equal to the median of this, and by extension this entire complete list, is equal to 1,976.5. And so if we look back at the answer choices, we can see that 1,976 is answer choice C.